Hi and welcome to this introduction to Goroutines. We will cover basic of this powerful feature in the Go programming language and provide example to help you better understand how it works. In Go programming language, coroutines are lightweight trait that allows for concurrent execution of code. They are a key feature that enable Go programming to be fast and efficient, particularly when handling I/O-bound tasks or when working with large datasets. Let's start with coroutines. They are created with Go keyword followed by the function name as shown below. In this code, we'll create a new coroutine that will execute duplicates concurrently with the main program. Goroutines are a great way to improve the performance of your program by allowing multiple tasks to run concurrently. One common challenge when working with goroutines is ensuring that all goroutines have been completed before the program exits. To address this issue, we can use sync wait group struct, which provides a simple mechanism for synchronizing goroutines. The wait group struct provides two methods, add and done. We use the add method to specify the number of coroutines we accept to run and the done method to signal when each coroutines have completed. We can then use the wait method to block until all coroutines have completed. Here's an example of how to use sync wait group. In this example, we create a wait group and add 5 coroutines using the add method. Each coroutine executes the myFind function, which does some work and then signals that it has complete using the done method. Finally, we call the wait method to block until all coroutines have completed. Next, let's talk about channels. Channels are used to communicate between coroutines. They can be thought of as pipes that allow data to flow between them. Channels are created using the make keyword and can be used to send and receive data. In this example, we create a new channel called myChannel, then create a new coroutine that sends the integer value 42 to the channel using the arrow notation. Finally, we receive the value from the channel and store in the variable results. Channels can also be used to synchronize the execution of coroutines. For example, we can use channel to signal that a coroutine has completed. The select statement in Go can be used to listen for variable on multiple channels at once. This is useful when we need to coordinate the behavior of multiple coroutines. For example, we can use a select statement to listen for value on two channels and then act whichever channel receive a value first. In this example, we create two coroutines, myFind1 and myFind2, each of which send the message to its respective output channel after a certain amount of time has passed. In this main function, we use a select statement to listen for value on both channels and print the first result then comes in. Finally, the context package in Go provides a way to propagate cancellation signal across coroutines. This is useful when we need to cancel a long-running coroutine or when we want to cancel multiple coroutines at once. For example, we can use the context package to cancel a coroutine after a certain amount of times has passed. In this example, we create a context with a timeout of 1 second and pass it to coroutine the myFind function. The myFind function uses a select statement to listen for either a completion signal or cancellation signal from the context. In the main function, we wait for 3 seconds to ensure the Goroutine has completed or be cancelled. If you want to use this feature of the Go language, remember that if you create many Goroutines, you must close them so that there are no problem with the performance of your application. Thank you for watching my video, and if you like this video, be sure to like and subscribe to my channel and turn on notification.